My name is Josh Mullis. I'm part of the blue team. We're with the voltage station, and we were going over the steady state and step response performance. Also on the blue team is Charles Sanford and Catherine Davis. A little bit about what we'll be going over today is the background of our system and a little bit of our analysis, some of the theory that we had to go through with the steady state, as well as the step function. Over a little bit of our results of the steady state operating curve and the step function, and then a little bit of our findings that we had. About the background of our system, we have a single input, single output system. As for our input, it's the percent input from a 5 horsepower motor, and it's going into our voltage station, and our output is voltage, and it's going to load lights. It's a little bit about our system. About the analysis of our system that we did. For the steady state operating curve, we had to put a constant input of the horsepower, what percent of the motor it was producing, and what we were getting out was basically the steady output of voltage over a period of time. As far as the transfer function or step function, we put, again, an initial input into the percentage of the horsepower in, and this was basically our user defined. And for our customer, they gave us a range from 10 to 70 volts for this. And we also had a defined step. And that right there, like I said, was the defined step. We also got to decide what time we did the step, and it was also if it was up or down. For both of these, the steady state operating and also the transfer function, we ignored the initial output until it came to a steady state. This right here is a little bit about, say, for our steady state operating curve. This is one of our examples that we did for 80%. Right here, the yellow line is the input that we had for our 80%. That's our input, and then our output. As you can see, here's our output that we got in volts. Probably around 12 seconds, 12, 13 seconds is when it hit our steady state. So once it came here, we took an average of this and graphed it onto this graph here. And this is where we got our steady state operating curve. And like I said before, we had a user defined from our customer. They told us that we had to do our thing anywhere from 10 to 70 volts. So therefore, we knew this range right here is our output operating range. And then this range down here, which is our input, the constant input, we knew anywhere from, I believe, 66 to about 82 is what we decided was our input operating range. And we used that operating range when we were finding our step function. We used the fit2 as well as also fit3 step function whenever we were looking at these. This right here, like I said, just gives a couple of the equations where K is delta CMS over delta the percent MS. Like I said, it also gave us tau and T naught. Most of us use the fit2. As far as our step function goes, we used that calculation there to find what our tau and T naught was. We let it go to a steady state, and then right here we were able to calculate it. It cut it off a little bit, but right here is where it got to a steady state, right at 17 seconds. So we were able to do, this was from our step from 66, and we did a step up of 2% for each of our graphs from all our step functions. And we brought it from basically 66 to a 68. And we did our step functions anywhere from 66 to 82. This chart here shows, we broke it into a lower, a middle, and an upper range. This chart here, like I said, I summarized all of our data, and we got it to, on a lower range, we got the average, the uncertainty. This is for the step up, the positive, and then we also had a negative. And this right here is our average and uncertainty for each. Once we did that, I broke it down, and I was able to find our parameters, where I averaged all of them, and we got our T naught to approximately 0.1 seconds. Our tau came out to 0.16 seconds. And our K, which is the steady state gain, came out to approximately 1.26 seconds. Another thing that we did find from our steady state operating curve was that our input operating range was from 66 to 82.
Could you click the postpone thing here? Those you just love Windows. How many love you? Raise your hand if you love Windows.
I've had like a virus,
I like
forever, it's bothering me
I like
about
it.
virus scans.
Excuse me?
Like my McAfee keeps on saying, so I don't have it, but I don't have viruses anyways, because it's like works the same. I'm pretty sure that McAfee is just like a virus itself. Like I put viruses on it, and it takes them off, just says, hey, look, I'm doing something, maybe more like serious.
So that we were able to find that our input operating range from the steady state operating curve was from 66 to 82. Then we're also able to find that our output operating range was from 10 to 70 volts, and that was a user defined by the customer.